Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. And today we're talking about 111 Edition 2 and 109 Edition 3 in your Saxon Blue books. And we're talking about simple interest and compound interest today. And interest is simply money that is paid for using money. So if your bank gives you interest money, it's because your bank is using the money that you put into the bank for their own money-making projects. When we put money into the bank is free to use our money, but they do pay a price for using our money. That's called interest. Now, if you borrow money, then you also pay interest because you are paying the interest fee to use the money that you are borrowing. So interest has a formula, and we're talking about simple interest now, and then a little bit later we'll talk about compound interest. Simple interest is principal times rate times time. Now in your book, they call the principal the amount. It is the amount that is either loaned or borrowed, and that is the principal. But we're going to call it principal because in almost every book you look in, it's going to call it principal instead of amount. So principal times rate times time is the formula, which simply means the amount of money you borrow or loan, the rate of interest that you borrow or loan it at, and then the time that transpires before you get your money back again or give the money back to the owner. Okay, so Jim put $5,000 in the bank for 2 years at 8% simple interest. How much money did he withdraw after the 2 years? So here, let's pick out our principal, our rate, and our time. So principal is the amount borrowed or loaned, and Jim put $5,000. So in this problem, the $5,000 is the principal, and the rate is the rate of interest, which is 8%, and 8% would be 0.08, wouldn't it? And that is going to be our interest rate. And the 2 years will be the time that it was put in the bank for. So the bank is borrowing the $5,000 for 2 years and giving you, or Jim, the money that is earned. And so this is actually 8% of the $5,000 is going to be earned every year. And there are 2 years. So now let's grab another board and do the work for this. Okay, so here we have our formula. 5,000 times the 0.08, that is what is earned every year. But then we multiply by 2 because it's 2 years. So we're going to take the 5,000 times the 2 is going to make it 10,000, and much easier calculation, right? So the 10,000 times the 0.08 is going to give us, remember the 0.08 needs to move 2 decimals over, so we can cancel 2 of the zeros and move the decimal place over. So 8 times 100 is $800 will be added to the account. Now the account already had $5,000 in it because it was a $5,000 deposit into the bank account. So we take the original $5,000 plus the $800 he earned in interest, and he is going to withdraw $5,800 at the end of the 2 years. Not bad. Now, your book does this a little bit differently. It figures out the interest for 1 year and then adds it twice. which we start with the $5,000, we add the $400 they make every year, and we still get the $5,800. So whether you use the formula, interest is principal times rate times time, or whether you just figure out the interest for 1 year and add it twice, makes no difference. I think the formula is easier. All right, so here is our second example. Maria deposited $800 at 8% simple interest. At the end of 3 years, she will have how much money? Okay, so we're going to use our interest formula. Interest is principal times rate times time. And let's look at the problem. And this was $800 is what she deposited. And so that will be our principal. So $800 is our principal. And the rate is given right here. 8% simple interest is going to be 0.08. And then the time is 3 years. Now time is always in years. So we're just going to put a 3. Okay, time is not in months or days or weeks. Time is always in years. So since it's 3 years, we just put a 3. So now we're going to multiply. So let's see, how can we do this the easiest way? We know that the let's do this. Let's take these 2 zeros and move this decimal over twice. That was easy, right? So now 8 times 8 is 64. And 64 times 3 is 12. And 18, 19. So she's earning $192 in interest added to her, she will have how much money means we take the original 800 and we add the 192. So at the end of the 3 years, she will have $992 in her account. That's pretty good. So interest is pretty awesome if you are getting it. But if you owe it, oh no, that makes it hard. Okay, now we're moving on to compound interest, which is a little trickier. Compound interest. Maria deposited $800 at 8% for 3 years. So that's the problem we just did, but we did it with simple interest. Now we're going to do it with compound interest, which simply means that the bank will take the interest at the end of each year and put it back into Maria's account so that now she has more money to earn interest on. So at the end of the first year, she has an 8% interest rate on $800. So 800 times the 0.08 means that at the end of the first year, we'll move these 2 and cancel those 2 zeros. So at the end of the first year, she has earned $64 interest on her $800. So at the beginning of the second year, she now has $864 in her account. And during the second year, she will earn 0.08% of that. Okay, so if she was pulling it out after the end of the first year, she would have earned $864. So we'll say after 1 year, she would have $864. So at the beginning of the second year, she gets that $864 as her starting amount, as her principal now. So now, at the end of the second year, she's going to have this much money as interest, which will then be added back into her account. So let's figure out what this is. We have 864 times 0.08, which is 32, and 48 plus 3 is 51, and 64 plus 5 is 69 with 2 decimal points. So she, this year, earned $69.12. So $69.12 is what she earns, added to what she started the year with. Okay, so let me get that up. Can you see that? All right, so now I'm going to take my $69.12 and add it to my $864 that I started the year with. So I'm going to have the 0.12 and then the 13, 12, 13, and 9. Okay, so at the end of the second year, she's going to have $933.12 at the end of the second year. So then we're going to take that as our starting amount for the third year. So now she's going to have this as her starting amount, 933.12, which is going to be multiplied by the 0.08. And then, that's a lot. So 2 times 8, I'm going to spare you and I'll do this. Okay, so when I multiplied that out, I got $74.65 earned in interest that third year. So then, wouldn't I have to take the $74.65 earned in interest and add it back to what I started the year with, which I did on another board because that one was really full. So here I took the $933.12 that I started the year with and I added the interest. And when I did, I got $1,007.77. So this is after 3 years with compound interest. And then from the problem we did before, this was the simple interest that Maria earned after 3 years. Compound interest was more, wasn't it? Because every year, the interest amount is put back into the principal. And then you start the new year with more money in your account, which means your interest is going to give you more because you've got 8% of a higher amount, and you're going to end up getting, over 3 years, the difference between the two calculations was $15.77, which over 3 years isn't a huge amount, but still, it's more. So compound interest is better if you are getting the compound interest. But if you're having to pay the compound interest, that's not good. Okay, so here is our next example. How much would $700 be worth in 2 years if the money was deposited at 9% interest compounded annually? So we're going to keep a little chart over here so we can keep track of our numbers. At the beginning of the first year, we are depositing $700. Okay, and we need to see what that is worth at the end of the first year, because that will be the starting amount for the second year. So we're going to say the percent is 9%. So 700 times 0.09 is going to be the amount of interest earned in the first year. So these two zeros will move these decimals over, the decimal over 2 places. So 7 times 9 is 63. So this is earning $63 in 1 year because we deposited 700 and took 9%. So we're going to add the 63 here to get the ending of the year amount. So that's going to be $763 that we're going to end the year with, which means that the start of year 2 is going to start with $763. So now we're going to take $763 and multiply that by 0.09. Okay, so now we can't use the little decimal move trick, right? Because we don't have zeros at the end. 3 times 9 is 27. 6 times 9 is 54 plus 2 is 56. 7 times 9 is going to be 63 plus 5 is 68. Okay? And then we have a 0. So now we can just put our decimals in. And the second year, $68.63 is going to be used, or $68.67. So we're going to add the 68.67 here, and the 0.67 is not going to change at all. And then 3 plus 8 is 11, 12 plus 1 is 13, 8. So we have $831.67 at the end of the second year. So sometimes making a little chart like this might help you keep your numbers straight. And that is the end of the examples. And now we're ready to do a couple of practice problems. Okay, so here is your first practice problem. And I want you to copy it down, and then we're going to pause our video for a little bit and see if you can do it by yourself. So Elvira put $7,000 in the bank at 9% simple interest. Okay, so now this one is simple interest. Okay, simple interest. So we're not compounding it like we did before. So we don't have to use our little boxes because it's going to end up not making a difference if we do it all at once. How much money did she get when she withdrew her money after 2 years? So on this one, we are starting with $7,000. Okay, and since the money is not going to be put back, she's going to end up basically not pulling out the interest until after 2 years. So basically this is going to stay the same until she pulls out her interest at the end of the two years. So we're going to say interest is principal times rate times time. So we can use this simple interest formula for this one. And we're going to say that her interest after 2 years is the principal, which was $7,000, times the rate, which was 9%. So we're going to write that as 0.09, times the time, which is 2 years. So after moving the decimals and dropping off the zeros, we have 70 times 9, and that would be 630. Since 7 times 9 is 63, 70 times 9 is 630, times the 2 is going to give us 1260. So $1,000, $1,260 in interest. So we're going to add the 1260, and we're going to wind up with $8,000. So we're going to put that $8,260 was earned with simple interest over 2 years. Now that we have found the simple interest and added it back, that was the simple interest. We added it back to the 7,000. So this is what Elvira would make after 2 years of simple interest. And we put it up there. So now the second part of your problem is to do the same problem, but now with compound interest. So we're going to have to take this out and this out. But now we're going to use the boxes to do the compound interest of the same situation. So we're going to go back to our little boxes over here. Starting with $7,000, we have to figure out how much she makes in 1 year at 9%. So 7,000 times 0.09, and my 2 decimals will be taken care of by the 2 zeros at the end, and 70 times 9 would be 630. So at the end of 1 year, she makes $630 to add to her 7,000. So now she has 7,630, which is what she will start the second year off with her principal. So now we have 7,630 times 0.09 0 times 9. 3 times 9 is 27. 6 times 9 is 54 plus 2 is 56. 7 times 9 is 63 plus 5 is 68, and 2 decimal places. So at the end of the second year, she has earned on that second year $686.70. 686.70. Now we're going to add those two, and we're going to end up with the 70 is going to stay, and then 6, and then 11, and then 12 plus 1 is 13, 8. Now she has $8,316.70. So the last thing we're going to do is find the difference between the compound interest over 2 years and the simple interest over 2 years. So we have $8,316.70 minus what we got before, $8,260.00. 6 minus 0 is 6. And 11 minus 6 is 5, and there's a 0 and a 0. So $56.70 difference between the simple interest and the compound interest. So the compound interest is better if you're the one receiving the interest. And that is the end of our lesson on simple interest and compound interest. And this is Mrs. A, and may God bless your day.